So here's our next problem. We have a 30-pound crate currently accelerating up at 6 feet per second squared. We have a cantilever beam here. So it looks like this is pinned, but picture there's support plates holding this thing up, okay? So put some bolts through. All right, so this is a cantilever beam. Then there's a pulley at the end. Here's this motor that's pulling on this rope, and we're asked to find the reactions here at A supporting this thing. All right, so what we need to do is, if you look at this, here's this beam. So with this being in tension, this pulling, so this is going to have to pull this to the wall. It's going to have to provide lift, and this beam would like to go this way, so we're going to have some moment coming back around like so to support that beam. All right, we're also told the beam weighs 200 pounds, so halfway along the beam we'll have that. And so this tension, okay, if I cut the rope here, there will be a tension going this way and a tension going this way. So that'll translate to the beam as well. So that means we're going to have tension here, tension there is the free body for the free body diagram at the beam. So we need to figure out what the tension is. That information is all sitting here very easily. Summing forces in the Y. There's a T up, a minus 30 pounds down. This has been on an exam in the past, and what has happened is many students just said, some forces equal 0, set T equal to 30, and said they were done. Wrong. You have to account for acceleration. So we have mass is 30 on 32.2 times acceleration, which is given as 6. Now if you solve for it, you find the tension's a little higher. So we have that. So now we have 35.6 here, obviously 35.6 there, and now it's just a matter of statics solving the rest of the problem. Okay, so if we sum the moments at A, well, it wipes out those two forces there. We would then have 200 here, so 200 times 2.5, that's negative because it's clockwise. All right, this is aligned with A, so it does nothing, and now here we have a minus 35.6 times 5, and then this is counterclockwise plus MA. Put a little at symbol there because this and that are different. Anyway, solve for MA, come up with 678 foot-pounds, and that's Z. If we simply sum forces in the Y, we have this. I have this going down. Obviously has to go up. AY is 235.6 pounds Y. And AX simply must counteract this one. So it does pull off in that direction, but when I vectorize it, I get minus 35.6 pounds X. And there is that one. More in a moment.